it is arguably the most critical issue in modern times. A driver of our changing climate. It has consequences in some of the most precious ecosystems on our planet. It is, of course, carbon dioxide. Professor Malcolm McCullock is researching the variation in carbon dioxide over the past several hundred years. His team of scientists are examining ocean waters and the CO2 signature locked within coral cores. His research has uncovered the influence of rapidly rising levels of atmospheric carbon dioxide on coral reefs. These increasing levels are a result of the burning of carbon trapped for millions of years within the Earth's crust as humans continue to exploit fossil fuels. It is not only causing global warming, but it has also changed the chemistry of seawater. Scientists have called this carbon dioxide from human-produced sources anthropogenic CO2. This is a new frontier in marine science. It will help us understand our past and future climates, as well as providing us with a better understanding of how the world's coral reefs will respond to the damaging effects of climate change. Coral reefs are the foundation of biodiversity in our oceans. As they grow, they record various aspects of the surrounding environment in their skeletons. Today, scientists can read past environmental parameters such as temperature, precipitation, and even anthropogenic CO2.
The reason we're here is that we're trying to look at the effect of CO2 uptake by the oceans, and we're looking at the effect of this dissolution of CO2 into the surface waters and how that's affecting the shallow water corals that are in this lagoon and on the outside of the Rowley Shoals.
Rowley Shoals is a remote reef complex 300 kilometres off the Western Australian coastline. Professor McCullock and a team have picked this location for good reason.
It's the most pristine reef probably in the world, isolated from river runoff, any terrestrial effects, and this will give us what the global climate change is doing to coral reefs.
Professor McCullock has developed a unique method for reading the past climate as it is recorded in coral cores, especially with regard to carbon dioxide. To extract this valuable information, the team need to find healthy, living coral that is several hundred years old. It needs to be a robust species that holds this valuable information within its calcium carbonate skeleton. The species that does this best is called Porites. Here in the Rowley Shoals, there are countless Porites, but relatively few of them are specifically what Professor McCullock needs for his research.
Want me to jump in?
Yeah, go in. Dive over. And we're looking for a nice large Porite, several metres wide, several metres high, but rather smooth on top, because that means the layers of growth layers are very regular and much easier to follow.
But how do we know if these pristine coral reefs are truly affected by anthropogenic CO2?
Anthropogenic carbon, which ultimately ends up as CO2, comes obviously, people know, from burning petrol in cars, fossil fuels, coal burning refineries for electricity are one of the other major contributors. Also making things like cement can also contribute. So as a result of all these, the CO2 in the atmosphere has gone up. It turns out that the burning of all the fossil fuels, the ultimate source of this extra carbon, has a distinctive isotopic composition, and it changes this in a certain particular direction. And we can see that in these coral records. When we measure the carbon isotopic composition of these corals, we can see that its composition changing in the same way the atmospheric CO2 composition is changing. This tells us that it's coming from industrialisation, fossil fuel, so the source of extra carbon in the surface waters is definitely labelled as anthropogenic CO2.
Back at sea, our scientists are still searching for the ideal Porites specimen.
We just ran over something which is, look at that.
Out of here.
Yeah, I think we should be able to do something with that.
It's big enough that you could probably find a space.
Yeah, and
Buoy on this one?
yeah, we'll put a buoy on this one, you reckon? I think so.
We've seen one of them, very large one, but the top of it was had died and had been overgrown. We've got a couple back there. This looks like a really good spot.
Oh, that's a good one.
Absolutely.
But we've got two good spots out here now,
Yeah.
so we're able to get up, go back, get the gear, start working. They're quite close to, sort of 100 metres apart. John, you want to come? Yep.
The team discussed their safety and strategy plans before the vital core is extracted.
This goes down, and then that locates the, locks the barrel in. Now the reason we work on Porites is, of course, you can see it's a very dense, uniform coral, very small polyps, and the layers are very well defined. In fact, we can sample it at a resolution of roughly fortnightly. So we can get changes of climate that occur at very fine resolution.
The drilling, however, proves to be more difficult than expected.
The corals have been living for at least 200 to 300 years, except that the drilling equipment we have here is proven to be limited a little bit because this particular site, the corals are very, very hard.
It has been difficult to recover a full core that covers the essential time period.
None of the cores we have so far go back beyond 1950, basically. So we want to try and capture that 1900 to 1950 period at least.
That night, the team makes some modifications to the drill.
And overnight it'll dry, okay? It'll be nice and tight by tomorrow.
The next day, the team try again.
A third of the way, it's definitely on the thread. 100% sure it's threading. We don't have anything that goes back to 1900. Hopefully, when they finish here today, we will have that. And that's why we've gone to the trouble of coming back to this site. Because I know I drilled it yesterday. We'd got down to a metre, which should be just about 100 years worth. Yeah.
As the divers set up, a humpback whale blows.
Oh, yeah.
It is a reminder of how spectacular, rich and important these marine habitats are.
What's the torch?
This detailed study on coral cores has revealed a far more burning issue that is changing the chemistry of seawater and the ability for corals to build their skeleton. It is known as ocean acidification.
Acidification comes from the dissolution of CO2 in surface waters, and it changes the carbonate chemistry, and it drives it into the direction of lower pH, lower carbonate ion, in a trend towards an acid composition, which of course dramatically reduces the ability of carbonate secreting organisms to build the skeleton. They're always subject to erosion processes and eventually reefs will be much more sparse and more barren. What we're trying to do is see if the coral growth itself is being affected. Is this part slowing down its calcification compared to earlier parts of the coral record? And if it is, at what rate? And then we can extrapolate forward and say, well, if we keep increasing CO2 at the current rate, calcification will essentially almost cease. And therefore we can help predict what is the ultimate threshold for sustainability, or that this particular species of coral will survive at. Now, other species may be more susceptible. We don't have data on the whole ecosystem, but this is one important piece of data. And it also critically is telling us exactly, well, giving us a good idea of what the surface waters are doing. We do not have instrumental records that go back more than about 20 years, and there are none in the Indian Ocean at all. The Indian Ocean has no measurements of this ocean acidification trend at all.
Finally, the team seem to have reached the target core depth.
So how would you describe that last?
Much better.
Yep.
Yeah, we've got a full metre there.
At the back.
And how much data would that contain?
That's 100 years of record, and we've got back to 1900.
Excellent.
Now we're proceeding back to 1800s.
Great.
So we've got another extension rod on. So this looks good.
Fantastic.
Super.
One and two there.
Walcott, this is Walcott 10 you received. We've got some good news. We've got all the cores. We've got data probably back for 100 years now, and we're just going down even further, and hopefully we'll have data back to 1800 on the next go, mate.
And essentially, what is the sustainability of coral reefs? That's a big question. How is climate change going to alter them? We know it's going to affect reefs. They're going to change. They're not going to improve. They're going to be degraded. But how severe are these changes going to be? How much time do we have to stop some of these effects from climate change? Do we have a decade, or do we have several decades? My own view is corals will probably have a bit more robustness than most people give them credit for, but we've got to understand it better so that we can take urgent action to keep our reefs at least in some reasonable shape for future generations.
Professor Malcolm McCullock's vital work on coral reefs is helping us to understand the story of past climate change, as well as determine the threshold CO2 levels that corals can tolerate. Coral reefs are of immense ecological and iconic value, as well as providing an essential marine resource. Understanding how they are responding to climate change will help us preserve these precious natural wonders.